What's up guys, welcome to my YouTube channel Freelance Coder, where people can be wrong but coding can't. This video is regarding data representation. So without wasting time, let's just start with our video. Let's see now what is bits and bytes. Now let's take an example of cube where this bigger cube is divided into 8 such small cubes. Now this small cube is represented as 1 bits, whereas this bigger cube is represented as bytes. Now in the given example we see that the bigger box is bytes. Bytes is nothing but the small representation of data. Its other units are KB, MB, GB, which we often use in our daily life. Now let's see how value is assigned to a variable. Now let's say this is a Python library. When we type a letter A, so A points to a memory location where in Python library it's have some specific value. Let's that value can be X. That means A is assigned to a value X, so that whenever we call A, then its value will be assigned as X. Now coming to our topic, binary system. Binary system is expressed as base 2 and has only two symbols 0 and 1. Now why we prefer binary system over decimal system in computer? First of all, let me tell you what is decimal system. Decimal system is nothing but the numbers from 0 to 9 which we use in our daily life. Now moving to our topic, computer uses voltage and voltage change often. So it is difficult to design an electronic equipment so that it can work with 10 different voltage level, that is from 0 to 9, where it is easy to operate with only 2 voltage level, that is on and off. That is why binary system is preferred over decimal system in computers. Now we will be converting this decimal number to binary. Now when we divide this number 43 by 2, we get quotient 21 and remainder 1. Now when we divide this 21 by 2, we get quotient 10 and remainder 1. Now when we divide this 10 by 2, we get quotient 5 and remainder 0. When we divide this 5 by 2, we get quotient 2 and remainder 1. Now when we divide this 2 by 2, we get quotient 1 and remainder 0. At last we have to again divided this 1 by 2, so we get quotient 0 and remainder 1. Now we have to take the reading from bottom to top, that is from MSB to LSB. MSB is nothing but most significant bit and LSB is nothing but least significant bit. Now this is the conversion of 43 to binary. Now we have to convert this number 147.51 to binary. So for this number 147, it is same step as the previous slide. Now we will be converting this 0.51 to binary. So we have to multiply this 0.51 by 2 to get number 1.02. Now the number before the decimal point we have to write it here. So now for the remaining part we have to continue this process and write the number. Now we have to take this reading from top to bottom. So we will write this number as 0.100. So we can say that the 0.51 in decimal is nearly equal to 0.1000 in binary. Now octal system. Octal system has a base of 8 measuring 8 unique symbols, that is 0, 1, 2, 3, 4, 5, 6, 7, where octal digit has its own value and weight expressed as a power of 8. Now we will be converting decimal number to octal number. So the process is same, but we have to divide the number 266 by 8. Now when we divide this number 266 by 8, we get remainder 2 and quotient 33. When we divide this 33 by 8, we get quotient 4 and remainder 1. So at last we have to divide this 4 again by 8. So we get quotient 0 and remainder 4. Similarly, what we had done in binary, we have to take this reading from bottom to top. So now the number 266 in binary is equal to number 412 in octal. Now we will be converting this decimal number to octal having decimal point. So we will be converting this 147.51 to octal. Now to convert this 147 to octal, the process is same as in previous slide. Now for this number 0.51 will be multiplied by 8 and we will get this number 4.08, from which we will took this 4 out and we will continue in the same process with the remaining part. So now after 2-3 steps we will get this number 4050. Now we will be taking this number from top to bottom. So 0.51 in decimal is nearly equivalent to 0.4050 in octal. Now for the number 147.51 in decimal, we will be adding this 223 and 0.4050. So we will be getting this number 223.4050 in octal. Here is the table that sum of decimal number is converted to octal. Now hexadecimal system. Hexadecimal system use base 16 and has digit symbol from 0 to 9 and alphabetical letters from A to F. It is used in computer to reduce large data in sets of 4 digits for easy understanding. Now we will be converting this decimal number to hexadecimal. We will be converting number 423 to hexadecimal. So when we divide this number 423 by 16, we get quotient 26 and remainder 7. Now when we divide this number 26 by 16, we get quotient 1 and remainder 10, which is equivalent to A in binary. Now when we divide this number 1 by 16, at last we get quotient 0 and remainder 1. So as we had earlier, we will be take this number from MSB to RSB, that is bottom to top. So number 423 is equivalent to 1A7 in hexadecimal. Now we will convert decimal number to hexadecimal having decimal point. So we will convert this number 147.51 to hexadecimal. 147, the process is same as we studied in previous slide. Now we will convert this number after decimal point, that is 0.51 to hexadecimal. So we will multiply this 0.51 by 16. We get number 8.16. Now we will take this number before decimal point, that is 8, outside, and we will continue this process with the remaining parts. So you can see that we get this number 8 to 8 after some steps. Now we will take this reading from top to bottom. So 0.51 is nearly equivalent to 0.828. Now we will add these two results which we get from number 147 and number 0.51. So number 147.51 in decimal is equivalent to 93.828 in hexadecimal. Here is the table of sum of decimal number converted to hexadecimal. That's it guys, thanks for watching our video and please like, comment and subscribe to our channel. Also follow us on Instagram, link is given in the description.